So let's dive into the first two steps in our recipe for designing a dynamic programming algorithm. Our first step is to define the subproblem in words. Recall our subproblem definition for some of our earlier examples. For Fibonacci numbers, we set f of I to be the ith Fibonacci number. In the longest increasing subsequence problem, we set L of I to be the length of the longest increasing subsequence on the first I numbers in the input. What are we going to do here? Our first attempt is always to try the same problem on a prefix of an input. So it's key. It's just identical to the original problem, and it's just on a prefix. So all we've changed is from doing it on length n to length I, first I characters. So let's formalize that. So we're going to have a variable I, which is the prefix length, and the prefix length varies between 0, corresponding to the empty string, and length n, which is our original input. And we define a new function L of I, which is the length of the longest common subsequence in the first I characters of x and the first I characters of y. Our second step is to define a recurrence. We want to express L of I in terms of L1 through Li minus 1. So let's take a look at how to define the recurrence in this example that we saw earlier.